Hi there, folks. In this lesson, we're looking at multiplying and dividing rational expressions. And really, multiplying and dividing rational expressions is the same thing that we've been doing since we've learned to multiply and divide fractions, okay? So if we look at these first two examples, these are just regular plain old fractions. We're going to approach this the same way when we get to the rational expressions. But when we look at something like this, some of you might multiply straight across and then reduce the fraction. The better way to do it is to reduce first. And remember, with these guys like the 4 over 14, you can reduce that, they're each divisible by 2, to a 2 over 7. Okay? But what many of you maybe don't remember is that you can also cross reduce. So anything in the numerator with anything in the denominator. So like here, I can cross the 7s out and say, oh, those are each divisible by 7. That's a 1 and a 1. And then I could reduce the 2 and the 12 to a 1 and a 6. Okay? And so now what I end up with is a 1 over 1 times a 1 over 6. Now I multiply numerator times the numerator, denominator times the denominator, and I get 1 over 6. Okay? Now I multiply straight across. So reduce first, then multiply straight across. Same thing here. Again, I can reduce the 9 and the 27 to a 1 and a 3. I could reduce the 25 and the 10 to a 5 and a 2. And now multiply straight across. It's a 1/2 times a 5/3. That's a 5 over 6. And that's it. Okay, but we want to take the same approach with rational expressions. The big difference is this. You understand how numbers work better than you understand how polynomials work. All right? So when you look at a 4 and a 12, you can immediately say, hey, those are each divisible by 4. Or a 4 and a 14 and say, hey, they're each divisible by 2, because you understand the factors of the number, okay? And you understand that 2 is a factor between 4 and 14, and you immediately cross it out without showing any work, okay? The difference with polynomials is we have to show that work, all right? So when we're multiplying rational expressions, we want to factor each polynomial completely. Then we're going to reduce the same way we were just reducing, and then we'll multiply straight across the way we just did that thing, okay? The big difference, again, is factoring it first, all right? So here I just look at each of these pieces and say, okay, how can I factor each of these pieces? So if I look at the x plus 5, how can I factor an x plus 5? Well, I can't. There's nothing I could do there, so I just leave it as an x plus 5. And then look at that denominator, the 7x minus 21. I can factor that. It has a greatest common factor of 7, so I factor a 7 out. Leaves me with an x minus 3. Over here, again, the 14 and the x, I just leave as a 14x. I can't really factor that any further. The denominator, I can factor that guy further, build a bridge, two numbers that multiply to a negative 10. I'll take it off to the side. But add to a positive 3 are positive 5 and a negative 2. I can use my shortcut on that one because the a value is a 1. So this factors into an x plus 5 and an x minus 2. So now this thing is factored completely. Now I start reducing and canceling out common factors. So like here, the x plus 5s cancel out. Here, the 14 and the 7 reduce to a 2 and a 1. And I think that's it. So now I multiply, and notice what I'm left with here is a 1 up top. So I multiply straight across. That gives me an x in the numerator. In the denominator, I end up with an x minus 3 and an x minus 2. And we could multiply that out, but I'm going to let you leave it in factored form here. So we can just leave it in factored form, and that's it. Okay? If I look at this one, again, this guy, we can treat it like a fraction, and so like over 1. But now I factor everything completely. So that first numerator, I can factor a 2 out. That leaves me with an x minus 7. The denominator, I can factor a 2 out. That leaves me with a 2x minus 3. This guy, I've got to build a bridge, two numbers that multiply to a positive 36 but add to a negative 13. That's going to be a negative 4 and a negative 9. And I can't use my shortcut on that one unless you went and learned the extra shortcut that I gave you, Secrets of the Universe of Factoring Method Revealed. So you're going to have to take that off to the side, split up the middle term, factor by grouping. And when you do that, you should end up with a 3x minus 2 and a 2x minus 3. Okay? And now I start looking for common factors. I notice these 2's can cancel out. The 2x minus 3's cancel out, so I'm just cross-reducing and reducing each fraction. Well, now I just multiply straight across. It's an x minus 7 times a 3x minus 2 over a 1. And really, I don't need the 1. And this one makes more sense than the last one to kind of multiply this out. That's a 3x squared, and then a minus 2x and a minus 21x is a minus 23x, and then a plus 21. And again, the reason I might multiply that out, if you leave it like this, if you leave it in factored form as just x minus 7 times the 3x minus 2, I will accept that answer, and that is fine, just fine. But you see, the reason I might multiply this one out is because now I can see that this thing's a quadratic, and I know how to graph quadratics. It puts it in a format that I'm familiar with, okay? But I'll accept the factored form, so either one of these. Okay. If I look at the next one, same kind of thing. I want to factor everything completely. And something like this guy, you can leave that as a 3x squared. If you want to break it off as like an x times an x or something like that, that's fine as well. All right, like you're factoring an x out. This guy, this numerator is a difference of squares, x squared minus 4. They're both perfect squares, so it factors into an x plus 2 and an x minus 2. Remember, difference of squares factor into conjugates. And then down here, greatest common factor, I can factor an x out. And now I start canceling out and see one of the x's cancel. If you left it as an x squared, you would just reduce the x squared and the x to an x over 1. And then the x plus 2's cancel out. And again, anytime you cancel things out with division, you're left with 1, so there's like a 1 down here. But now I multiply straight across. That's a 3x times an x minus 2 over, looks like in the new denominator, I only have an x plus 3 left. Okay? If I look at the next one, again, same kind of thing, factor everything completely. So this numerator, I can factor a 2 out. That leaves me with a 2x plus 3. The denominator, build a bridge, two numbers that multiply to a negative 12 but add to a positive 1 are going to give me a positive 4 and a negative 3. And again, I can use my shortcut that time because the a value is 1. Over here, x squared minus 9 is a difference of squares, so that factors into conjugates, x plus 3 and an x minus 3. And then in the denominator, build a bridge, two numbers that multiply to a 6 but add to a 5 or a 2 and a 3. You can't use your shortcut on that one. Take it off to the side, factor by grouping. You'll end up with a 2x plus 3 and an x plus 1. Okay? And now I start looking for common factors. The x minus 3's cancel out. The 2x plus 3's cancel out. And I think that's it. So now in the numerator, I have the 2 times the x plus 3. That is a terrible looking 3. I can do better. I'm better than that. Not much better, apparently. And then in the denominator, I'm left with the x plus 4 and the x plus 1. And we're not worrying about domain restriction, that kind of stuff with these questions. Obviously, we could talk about that, but we'll save those for the previous examples, okay? For now, we just want to reduce. We just want to do the multiplication, okay? So that's multiplication. Let's talk about division. And if you remember how to do division when we're talking about regular fractions, then you probably have already figured out how to do this. But if you recall, remember, dividing by a fraction is the same as multiplying by the reciprocal. So dividing by 7 over 36 is the same as multiplying by 36 over 7. We flipped the second fraction and changed to multiplication. Now I'm doing multiplication. I'm doing what I did on the previous page. I start reducing. I multiply straight across and I get a 9. This one, same kind of thing. Dividing by a fraction is the same as multiplying by the reciprocal. So I flip that second fraction. Now I have multiplication. I can start reducing. I can reduce more. That's a 1 and a 1. I multiply straight across and I get a 1. Okay? But again, division just becomes, when you're dividing by a fraction, division just becomes a special case of multiplication. All right? So dividing rational expressions, literally the same thing as what we did with these fractions up top here, okay? We're going to change division to multiplying by the reciprocal, and then the next 3 steps are the same steps that we did on the previous page. Factor, reduce, multiply straight across, okay? And again, you can leave it in factored form, and that'll be fine, just fine. So this is exactly what we just did with one extra step at the beginning. So here I've got b squared plus 4b plus 4 over 2b squared minus 8. I'm going to change division to multiplying by the reciprocal. So I flip that second fraction, and now I'm doing the same thing that I just did on the previous page, okay? So I start factoring this thing. So here we go. The numerator, I can factor that into a b plus 2 times b plus 2. And you could write it as a b plus 2 squared if you want. I'm just going to leave it as b plus 2 times b plus 2. The denominator, I can factor out a 2. Let me take that off to the side. When you factor the 2 out, it's a b squared minus 4. That is a difference of squares, so b plus 2, b minus 2. And see, the better you are at factoring, the easier these problems are. Okay. Up here, the numerator, I can factor a 5 out. That leaves me with a b minus 2 over, that's a 4b. And now we start crossing some stuff out. Those b plus 2's cancel. The b minus 2's cancel. So now in the numerator, I get a 5 times b plus 2. In the denominator, I have 2 times 4b, which I'm just going to write as 8b. And that's it. Okay? So again, we're doing the same thing we did on the previous page, but we have one extra step to start. We change division to multiplying by the reciprocal. Okay? Down here, these look complicated, but don't let them fool you. Remember, a fraction bar is a division bar, so if you think about this division bar in the middle, or this fraction bar in the middle as the division sign, you could write it like this first as 4x plus 6 over x squared plus x minus 12, and then change it to divided by 2x squared plus. All right, so if it makes you feel more comfortable to change that division sign, or sorry, that fraction bar to a division sign first, that is fine. You can do that. And now let's change it to multiplying by the reciprocal. Most of you are probably not going to show that first step that I just showed. And that's okay. And if this now looks familiar, it's because it is. We did this one on the previous page. But here we go. Let's work through it. So here I can factor a 2 out. Leaves me with a 2x plus 3. Denominator, build a bridge. I get to use my shortcut. It's an x plus 4 and an x minus 3. Over here, difference of squares, x plus 3, x minus 3. And then the denominator, take it off to the side. Build your bridge, split out the middle term, factor by grouping, all that fun, wonderful stuff. And now start canceling. These guys cancel. These guys cancel. So I'm left with, let's see, a 2 times x plus 3 over an x plus 4 and an x plus 1. But again, once we're past that first step, it's literally the same thing that we've been doing, okay? So if I look at the next one, again, I'm going to cut out that first step that I did. I'm going to go right to changing it to multiplying by the reciprocal, if I can somehow scroll up here. So again, think of this guy. This is my division symbol. So multiplying by the reciprocal, that's going to be a 3x squared minus 7x plus 4 over 4x. Notice the first fraction never changes. And then instead of divided by, I'm going to do multiplication. And I flip this second fraction. So I flip, so it's a 12x squared plus 8x over the 2x squared minus 20x plus 18. And now it's just factoring. That first numerator, I build a bridge, two numbers that multiply to a 12 but add to a negative 7 or a negative 4 and a negative 3. You can't use your shortcut. Take it off to the side. It's going to be a 3x minus 4 and an x minus 1. And yeah, I can do those in my head because I've had a lot of practice and I know a shortcut. The second numerator here, I can factor the greatest common factor of 4x. Leaves me with a 3x and a plus 2. And then down here, I can factor a 2 out first. And if I take that off to the side, it's always good to take things off to the side if you're not sure. Take it off to the side. If I factor the 2 out first, leaves me with an x squared minus 10x plus 9. And now build a bridge. Two numbers that multiply to 9 but add to a negative 10 are a negative 9 and a negative 1. And I get to use my shortcut now because I have a 1 out front. And again, my 9s are not looking good. I'm having a little trouble. Sorry, my computer's starting to slow down. It's working too hard. And now I start canceling some things out. So the x minus 1s cancel. And the 4x cancels. And I think that's it. So now I got to write my end result here. Let's see. It's a 3x minus 4, a 3x minus 2, plus 2, over the 2 and the x minus 9. That's it. So I just cancel everything that I can. I multiply straight across. All right. So again, multiplication, factor, reduce, multiply straight across. Division, change it to multiplication first, multiplying by the reciprocal, then factor, reduce, multiply straight across. Okay?